Hey everyone, my name is Shashank Kalanathi, and in today's course, I'm going to be teaching you guys how to use R for data analysis and data science. The purpose of this course is to teach you just the core basics of the language and some stuff about the tidyverse series of packages, which will get you where you need to go in order to start doing basic data manipulations and basic data analysis, from where you can start adding in more knowledge as you need to for whatever job you happen to be working in. We'll first start off with learning the absolute basics of the language, and from there we will then go to learning about the tidyverse series of packages, which are really good for cleaning and analyzing data. If this is your first time coding, or this is the first coding language that you're learning, don't worry if you have to watch this video a couple of times. I know when I first learned how to code, it took me forever to learn how this stuff worked. Be sure to watch this video a couple of times. If it's your first time learning stuff, then it might take 3 to 4 different watching periods in order to fully understand and absorb all the information that we have over here. If you haven't already, make sure to click on the link in the description below for the notes on this course that have a written version of basically what I'm saying to you right now, and will have the code that you can use to run alongside this course. Another small tip. Coding is not a spectator sport, and you need to be coding alongside me in order to have a chance of learning how any of this stuff works. So make sure that you're actually learning to code by coding while I'm doing so on the screen and not just watching the video. All right, so right before we get started, what is R and what does it do for data analysts and data scientists? So R is a statistical programming language used for many different applications, but is one of the 2 primary programming languages used in data science and data analytics, the other one being Python. R can help you do all kinds of things, from cleaning up data, to analyzing data, to performing machine learning algorithms on data, to creating really great analytical outputs, PDF documents, graphs, charts, stuff like that, that can explain a point of view that you have to an audience. R kind of operates as a catch-all tool within the data science space. You can basically do anything you want inside R. If you want to learn a little bit more information about R, then go ahead and check out my notes under the section that says what is R and what does it help data analysts do. There's a link that says datacamp.com where they have a blog post all about R that does a great job explaining exactly what R does in data science and why you should learn it. But without further ado, let's go to the computer and let's get started coding. All right, well, let's get right into it. So we're going to be working with R using something called an IDE, which is an integrated development environment. Whenever you write code, an integrated development environment or an IDE is primarily what you'll be using to actually write your code. And the thing is, if you think about it, when you're writing code, you could literally write it in any text pad or even a Word document if you really wanted to, and then save it as a .r file, which would then make it R code. But what an IDE does is it provides you a lot of tools to help you with the grammar of coding, like things like, well, not spell check, but it'll have like auto completion for you. You can easily search through all your variables. So people normally code using an IDE, even though it is not strictly necessary. In fact, I personally don't really know anyone that doesn't code with an IDE, although I'm sure there are some particularly talented programmers out there who don't use one. So RStudio is like the default IDE for R. So we'll be going and using that. So as you can see over here on the left-hand side, we have the notes for this course. I highly recommend you have these on the side as well as you're following along. I also recommend you follow along. Programming is not a spectator sport. You have to participate in order to learn it. So you'll have the notes over here, and it'll say installing R in RStudio. You can click on this link over here, or if you just go to rstudio.com, you can then go to Products, RStudio, and then click on RStudio Desktop and download RStudio Desktop. It should take you to a different page, and then just go for the free version. Don't worry about the rest of these things. Those are for companies and stuff like that. So what you'll need is you'll need 2 things. You'll need the programming language of R, which is what you download over here. It looks like, what version are we on right now? Should be like 3.4.2. Oh, download R for Mac OS for me. Yeah, 4.2.1. Yeah, and I think I have an Apple Silicon, so I'm going to download this one over here. If you have an Intel Silicon, you download this one over here. And you can check by, I think, going to the upper left corner over here, going to About This Mac, and it'll say something like Apple Silicon or Intel Silicon. The reason I'm not going to click on that is because my device's serial number would be there. So I'm going to click on that and then download it. And then I'm going to go back over here Oh, sorry, I'm going to go back to the RStudio page, and then I'm going to download RStudio for Mac. Download that as well. And then I'm going to click on this to install R first, then I'll install RStudio. I don't think the order actually matters, although I would definitely recommend installing R prior to installing RStudio. And you'll notice that R actually has a lot of funny names for each version that gets released. So version 4.2.1 is a version funny looking kid. Just the standard stuff, install it, put in your password. And then close, move to trash. And then now we can download, or we can install RStudio. And that's as simple as dragging and dropping over here for Mac. Again, if you're on Windows, it's going to be slightly different. All right. Well, there we go. Now we have installed R and RStudio. So, like I mentioned earlier, the reason we installed IDE, or an integrated development environment, is to work with R files or RMD files. So if you see a file that has a .r file extension, then you know that it is an R file. But we'll be working with these things called R Markdown files, which have the extension RMD. And if you've ever used Python, you might be familiar with Jupyter Notebooks. The R Markdown file, which can also be rendered as an R notebook, is very similar, and it's basically R's version of the Jupyter Notebook. And instead of R, like just a text file, what you can do is you can, if you see over here in this picture over here, which is from the RStudio website, the left-hand side is just code, and then like, this graph over here, which then renders to something that looks a lot prettier when it, renders out. This is why we use the R notebook file. Also because the R notebook file format allows us to run code in little chunks instead of running the entire file all at once, which can make it easier to troubleshoot your code. And the reason that a lot of data scientists and data analysts use R Markdown instead of just a straight R file is because when you present an analysis, usually you'll run some code and then you'll show the result of it, you present that result, and then you run the next bit of code. Versus if you're a software developer, you're obviously running code to it performs a function of some kind. And that's why software developers don't really use this notebook format the way data scientists and data analysts do. I'll show you guys how it works in a bit. So let's go ahead and open RStudio. So I'm going to go ahead and hit Command Space on my computer. And I should just be able to hit that. It'll be in your applications folder if you are on a Mac. Might just have to give it a second. All right, so I actually had a previous installation of R on my computer. That's why you'll see mine looks a little bit different from, say, what yours probably looks like. It's a lot more zoomed in, for example. And let's see. Yes, that should be easy enough to read on the video. And let's go ahead and shrink this a tiny bit. There we go. And then we'll expand this a little bit, give you guys more room over here. All right, so this is RStudio. Let's go ahead and create a project. So what you want to do is you want to go to File, New Project, and it might take a second to run. So my computer is recording and outputting video at the same time as it's doing this, so certain things take a second to run. And then we're going to create it in a new directory, New Project, and then we'll call this R, let's see, lesson. And we'll put it under the R tutorial, create project. All right, there we go. So we have a new project right now. And basically what a project is RStudio will save a file in the .rprog, so .rproj file type. And what that does is that basically has a bunch of settings that will allow you to organize a bunch of files together in an R project. Long story short, every time you do a new analysis of some kind, I recommend making a new R project. It's nothing more than kind of a project space for you to put all your files in. And it organizes stuff, maintains all your settings, stuff like that. Nothing to think too hard about. All right, and then let's go ahead and create an R Markdown file. So I'm going to click on this button over here. If you're on Windows, you may not see this over here, in which case go up to the upper left corner, and then you can click over here and then create a R Markdown file. And then I'm just going to call it, let's see, first file. Let's see. And then, yeah, let's click. Oh, and then make sure HTML is checked, and then click OK. And you'll see it opens up like this. So then go ahead and download the course files into the same directory over here. So let me go ahead and show you guys where that is. So for me, it would be here. And I want to download the files over here. So I've already run this lesson once, just testing it out for you guys. So I'm actually, what I'm going to do is I'm going to cut this. Or I get yeah, let's just copy it. Copy. Paste. And these are the data files that you're going to be using inside our little project over here. So you can go ahead and download them using this link in that's inside the course notes. So go ahead and click on that link and you can download the Google Drive folder. And then make sure it's inside a folder called Data. All right, so let's take a small step back and look at what is this we're actually looking at. What is the RStudio layout? So I'm going to go through this. You'll see there's kind of like 4 quadrants over here. I'm going to go through this kind of the way you would mathematically, right? Starting with quadrant 1 over here. So quadrant 1, this is called the Environment Explorer. And this is where whatever variables you're working with in your current running instance of R, they'll be saved over here, along with like, any stuff you're connected to. There's even a tutorial to show you how stuff works. And then a history of stuff over here. But we'll mostly be using the environment section of this area over here. Under quadrant 2, you'll have your coding panel. So you'll see like, there's a bunch of code over here. And this is where you'll actually end up writing your code. Quadrant 3 is your R console and system terminal. So you'll see over here the R console. You can actually write code directly in here, line by line. And what that does, that basically will execute the code line by line. Usually you want to write a bunch of code all at once and then execute it all at once, which is what we'll use the coding panel for. But if you want to just execute individual statements, you can do so in the console over here. And if you click on terminal, you'll see that this is actually the terminal that is attached to your computer. This is like your computer terminal. So you can use this the same way you would like command prompt or your computer terminal. And then quadrant 4 over here is your file and plot explorer, where you have your various files, any plots that you create, packages you install, stuff like that. We'll talk about this a little bit later, but this is where a lot of your kind of like what you call like environment management would be. And so you'll notice in my notes over here, I have a link, and this link goes to the, I have a couple of these inside the notes, and basically what they do is they open up these cheat sheets that the people at RStudio created. One thing I will say about R and RStudio specifically, the RStudio, I guess, company, if you can call it one, is that they have like these tremendous cheat sheets and tutorials, and they're like kind of on board, like their teaching tools are some of the best out there. Like they're some of the best in the data science world, in my opinion. So you'll see they have a similar kind of like a much more complicated overview to what I did, but a lot more detailed than what I did. So I would recommend taking a look at this when you get the chance to as well. They have a bunch of these cheat sheets. All right, let's go ahead and get started. Oh, it looks like I accidentally didn't create my first file, so let's go ahead and try that again. R Markdown. And then we're going to call this, what was it? First file, I believe. There we go. Okay, so in any programming language, like, in R, we have these things called variables. And variables are used to store values, which we can then change, combine, or output later. So a variable would be something like x equals 5, or like y equals 6, or like x equals shushank or something, right? So you basically just store a value inside it. That way you can reference it a lot more easily, and you can dynamically insert different values into like functions and stuff that you create in the future. So variables are kind of like the core of a lot of, object-oriented programming. Well, objects are the core of object-oriented programming, but that's a whole paradigm of things worth going into. Let's not worry about that right now. But variables are where you store values, which will, they're going to be the core of what you actually change and manipulate, which is what you're trying to do. You're trying to change and manipulate variables to like eke information out of data. So in R, there's a couple of, there's this thing called variable assignment that, is also in Python or other programming languages, where basically, you assign the value 5 to X, you assign the value 6 to Y or something like that. And there's a couple of rules. You have to pull a state case, which is this whole all lowercase, and then every new word is separated by an underscore. All R variables need to start with a letter or a period, or a period followed by a number. And in R, we use the less than hyphen, so this arrow, this backward pointing arrow basically, or this left pointing arrow, to assign variables instead of what you'd be familiar with in Python, which is the equal sign. You can also use this equal sign in R, but I recommend following the left pointing arrow because it's what more R practitioners in the data science space would use. And there's a really great, I don't know if it's a quote, but there's a really great saying I read in some Microsoft documentation once, where they basically said code is written, or code is read a lot more than it's written, which is why readability is very, very important for code. And it's why you don't want to do special things with your code. You don't want to have like your own syntax, honestly. If you can avoid it, you want to use standardized syntax wherever you can. So let's go ahead and, stop talking. Let's go ahead and create our first variable. So I hit the enter button, and I'm going to hit x less than hyphen 2. And then I'm going to hit enter again. So we've assigned x to 2. And then I'm going to put it in parentheses and type x. Now what this does is, in a lot of languages, you have to write print or println to actually like display a value in the console. In R, you can just use parentheses around a value. So we did that, and let's go ahead and click on the C over here, and then click, wait, sorry, my bad. We're going to click on, you know what? Clear all that. First of all, click on this C, click on this R. We added what's called an R, like a coding block now, right? So add a coding block first, then do the exact same thing. So x equals 2, surrounded by x, and then I'm going to hit this little go button, this play button on the upper right corner of the little cell block we created. And you'll see we get the value 2. We're printing out x, we've assigned the value 2 to x, and therefore we get 2. So sorry for the confusion. What you have to do is you have to create a new R cell block prior to actually, writing any R code. What we were writing in this white space over here is just text. It's just plain text. And I'll show you how that works in a second. Okay, so the next thing, we want to go over a couple of variable types, right? So variables have different types which inform to you what they do. And a good example of this, for example, is that the number 2 encoded as a number, as it is over here, this is the number 2, will not be the same as 2 encoded as text. So for example, if I was to surround this with little quotes, even single quotes, now it's text. It's not the same thing as a number 2. You can test what the type of a variable is using the type of operator. So let's try out with the x we created earlier. So I'm going to go to line 7 here, and I'm going to create a new R code block, and I'm going to type in type of, and you can see this is kind of what an IDE lets you do. I'm going to go down one, enter, and I'm going to hit X, and then let's go ahead and run this. And you'll see it says double. What double means double precision number. Yeah, I was about to say integer, but it means double precision number. Long story short, this is basically just a method that computers use to say numbers. There used to be these things called single precision numbers. I mean, they still exist. It's just that there's so much memory available to us these days that most use cases you're not really worried about optimizing at that level. At least for data science applications. And so that's why we are looking at that's why this is called a double. It basically means this is a number, which can also have decimals and be negative. So it's not the same thing as an integer, for example. So we'll see that R automatically assumed that the 2 was encoded as a number. Now, let's say I try this, right? Let's say I surround this with single quotation marks and then hit that. So now it does this, right? And then I run type of again. You'll see now it says it's a character. It's changed its variable type. So let's go over the basic variable types you can have. There's these things called logicals. So I can go ahead and do z is equal to true, and then take the type of z, and then run that, and you'll see it says logical. So logical can be either true or false. I believe there's also a null value in there. Almost every data type has a null value. I believe all of them have null values. Null just means no values there. And a logical type is also called a Boolean type in other languages. And it's basically is something true or false. You know, that's what a logical type is. It's something true or false. We're not going to be using that much in this course, but I want you to be aware that that exists. I'm going to go to line 12 and insert a couple of lines just to give us some space. And also, pardon me, I'm kind of like losing my voice right now. So, you know, if I kind of take a break for a second, I'm just catching my breath for a minute. So now I'm going to go insert a new code chunk, and then I am going to, well, we've already done double. There's one thing that you should know about doubles, right? So let's make x equal to 13, for example. Type of x, and then run that. You'll see it says double. There are 4 special values that doubles can have. Either NA, which basically means null, negative infinity, NaN, which means not a number, and infinity. And these are like small mathematical quirks, so you can do things like, NA just means that there is no value. I believe that you can literally just type in NA. Oh, but it assumes it's a logical, right? So what I can do is I can do like as dot double if I want to convert it to a double. And see, now it's a null double type, right? So you can do that with a lot of types. You can do like as dot integer, as dot logical, or allows you to change data types if you want to. I could also do, I believe, -1 divided by 0. So then what I would do is I would actually just print out x over here. And you'll see that's negative infinity. I could do 0 divided by 0. That'll get us NaN. And I can do 1 divided by 0. Basically, stuff divided by 0 does funny stuff, right? Presumably, I can make this any number I want, and it would give me the same amount, right? And, you know, if you've taken your math courses in high school, you'll know kind of the logic behind how this stuff works over here. So, again, I wouldn't worry about that too much, but just in case you see these values, that's how you get them, through -1 divided by 0, 0 divided by 0, and 1 divided by 0, or the value just doesn't, it's not, it's null. So, and remember, null and NaN are not the same thing in R, whereas in Python, depending on the library, I believe it's the same thing. Don't quote me on that. Next, we have the integer type, which is basically integers are numbers that don't have decimals to them. So if I say x is equal to 1, so R automatically makes it a double, but I can always turn it into an integer using the that familiar operator you saw, as integer. And you'll see now it's an integer. There's really no like advantage to it at this point in time. I just want to make sure you're aware that it does exist. You can also put a capital L at the end of the number, and that'll also make it encode to an integer. The L, I believe, stands for long. And the logic behind long, there's a lot of extra information I've added in these 2 links over here. Again, not really the point of this course over here. I just want to make sure you're aware of these basic data types because they are integral to actually understanding the language in the future. These are just like the basics you have to know in order to do anything with the language in the future. So you can click on these links over here to get more information as to why that L is necessary. Then, because obviously R is a statistical language, you have the complex data type, which can be created through using the letter I. So you'll see it says complex now, and if you're familiar with I is basically the square root of -1. this is a complex number, and it is, again, we're not going to use it in this course, but, good to know that it's there. So you'll see this is like kind of the format that we write complex numbers in. So 3 times square root of negative 1 plus some number to it. Then there's obviously the character. I'm going to copy, actually, yeah, I'm going to copy these over here. Oh, you know what? No, I'm not going to do that. The next is a character, which is basically like, it's just text. So if I say, for example, I can create characters in 2 major ways. So I can use a double quotes. I am learning R. That is a character. I can also use single quotes, as you probably saw earlier. Whoops. That is also a character. So let's see. Let's do type of Z. So that's a character. Obviously, if I use double quotes, we still have a character. This isn't true in every programming language, but it's true in Python and R. If, let's say you wanted to have a single quote inside there, if I have double quotes on the end, then I can even add these single quotes there, and then you'll see it'll still print out the single quotes over there. You can also do this thing called an escape character. So let's say for whatever reason I wanted to say this, right? So you'll see this kind of breaks apart the whole string over here. What you can do is you can use an escape character, in which case, this case, the backslash. And what that does is that the escape character says, print the next character literally. So you'll, when you're actually printing it out in a console, it won't look like that. But what it's saying is like print this next character out like quite literally, instead of getting rid of it the way we, or instead of like absorbing it like a double quote and saying this is a string, just print it out literally. Another thing you can do, you can also use these things called new lines. So if you do \n, then what that does is when formatted correctly, it'll actually print out stuff on a new line. So a new line just is the same thing as hitting the enter key. Funny story, Macs and Windows actually handle new lines slightly differently. Once you start working with a lot of CSV data, you'll start to see some really weird quirks with the way specifically Windows computers handle data. They have this weird line break, which is kind of hitting the enter key thing I was talking about. They have this weird line break logic that like no one else uses. That can get really, really confusing. So I think it's called a carriage return or something like that, which can be really annoying. I believe you can also do multi-line strings in R. So I think I can, yep, you can just do this in R and it'll create a multi-line string. This is special because you can't do this in Python. So you'll see now it inserted 2 line breaks automatically. Line breaks, new lines basically means the same thing. In Python, because formatting is really, really important, you can't just do that in Python. So you have like something called a multi-line string. And if you hear me referencing Python a lot, I do that, 1, because I'm very familiar with Python, but 2, also because I expect that this course will be watched by a lot of people who already know Python and want to learn R because they are data scientists or data analysts who are, looking to learn. So I mean, that's basically all you need to know about strings. Easy enough. Next, in R, you have these things called vectors. So let's create a new one. And then you create them, and a vector is basically it's called an array in other programming languages. And it's basically a series of variables that are of the same type. So I can do, you create them by using the C operator, and then I can run that, and that is a vector. So if I say y equals that, and then we do type of y. Oh, sorry, and it'll give you the type of what's inside the y. I think if I type in... no, yeah, it's just giving me the... whatever's inside there. And the thing is, everything has to be the same data type inside a vector. So for example, if I make this a character, it'll automatically turn the whole vector into a character vector. Because you can convert all of these into characters, but you can't necessarily convert them back into numerics, or not without doing a bunch of checks to make sure stuff actually works the way it should. Also, a small note on characters, one thing that I should note. So you'll notice that, you might be asking the question, why, for example, would we ever want to encode a number as a character? A great example is American zip codes. Zip codes are the equivalent of postal codes in other countries in America. And basically, in America, in the Northeast, right, you can have zip codes that look kind of like that. They start with a 0. And the thing is, if you save this as a number, right? So, I mean, I can even show you how it works, right? So I'm going to create a new code cell over here. And I'm going to say Z equals that, Z. You'll see what it does. And then let me even... So you might have noticed how I didn't put the parentheses around it and it still printed out the result. Excuse me. In an R Markdown file, if you just put the variable on the last line, whatever's like on the last line directly by itself without any assignment or anything, will just be printed out. But I want to print out two things, so I need to do this. So you'll see it converted it to a double, and by doing that, obviously no numbers start with a 0. And this is a reason why you might want to use a character. Now you'll see it preserves that 0 over there and keeps it as a character, because in American zip codes, some of them can start with zeros, which is really, really annoying because, you know, in like computers will chop off that leading 0 unless you directly specify that they shouldn't. And this is why you might want to use encode a number as a character. Basically, numbers with which math cannot be performed, i.e. zip codes, because, you know, 0, 1, 2, 3, 1 is no better than 90210 or vice versa, and you can't like add them up or anything. So no math can be performed. So zip codes in which, numbers in which no math can be performed should be encoded as text, in my opinion, because it means that data can be lost if you don't do that. Usually if you have like leading zeros. So this is also called padding, basically when you add zeros at the left-hand side, or, well, I guess you can pad left or right. So when you add zeros to either end, that's called padding, and it's something you use for a lot of identification numbers, which, you know, a postal code is kind of an identification number in some ways. So yes, back to the vectors. So we've gone over that. We've gone over that vectors can only be like a single type. Another thing you can do to create a vector that's pretty cool. So R has a lot of great like syntax for like shortening stuff. You can do this, right? And I hit Command Enter or Control Enter just now, which is how I can like run the line that I'm on in a cell. And you'll see it created a vector of 1 through 5 by doing 1 to 5, and then I can change this to whatever I want. So like I can do 1 through 10, Command Enter, and it'll go 1 through 10. You can also do, if you want more control over this, you could do something called seq, SEQ. I think it's called a seek. So if I do like seek vector, then I can do SEQ, and then I can do 1, 10, and then length dot out equals 5. And you'll see what it does is it goes from 1 through 10 inclusive, meaning that it'll actually include 1 and 10. And it'll create a vector equally spaced with 5 values inside it. If I made this 100 well, I guess 100 wouldn't be easy to read. Then, you know, you see it'll go 1 through 10. And I can even do 9, for example. And you'll see it'll go up to 9. So this is an easy way to, this is kind of just an expansion of the syntax over here. So you'll find that languages like R and Python have a lot of like short syntax that's like really cool and easy to use. All right, so those are sequence vectors. Now let's see what are some operations you can do on vectors. So let's go ahead and create a new, code block. And then I'm going to go ahead and copy this over here just to explain each and every one of them. I'm going to run that. And let's, oh, and one thing you might have noticed is, remember how I said this is like, you know, you can explore your environment over here. So you'll see every time we update what one of these variables means, we can see it over here. So this is one of those cool things that an IDE allows you to do that, say you were writing this code on just a notepad or something, you wouldn't get this kind of view over here. So you'll see over here, we created a vector 1, 2, 3, 5, 6, called it Z. If you want to get the first value of that vector, then you can just use a bracket and then put in the number of, whatever value you want to get. So if you put in 1, you'll get the first value. R is a one-based index language, whereas like a lot of other languages, Python, for example, is 0-based index, meaning that Python indices start at the number 0 and then go up from there. I've heard people say that 0-based index is like definitely the way to go. I don't have an opinion on it. I don't know why it matters, but someone who might be more educated on different programming languages than me, maybe you can tell me in the comment section below. If you want to get the first through the fourth values in a vector, then you can use 1 through 4 over here. If you want to get specific values, then you can create another small vector in here. You'll see this little C that we create another vector within here, and we're getting the first, third, and fifth values. And if you want to get all but the first value, then you just do -1 or -4 if you want to get all but the fourth value. So those are just a couple of operations you can run on vectors. Ooh, another cool thing you can do with vectors, you can do all kinds of different mathematical operations with them. So I'm going to go hit this, and then run that. So again, if we create a new vector we call vec, and you'll see vec showed up over here under our variable explorer. 1 through 5. If we take the sum of vec, we get 15. The minimum value of vec is 1. The maximum value, so you can do like min parentheses, put a vector inside that, max parentheses, put a vector inside that, sum parentheses, put a vector inside that. Maximum value is obviously 5. Range is going to give us 1 and 5 because, the range of the vector is 1 through 5. And then length is just going to give us how long that vector actually is. So these are just a couple of operations you can run on vectors. And if you want to know more about different operations you can run, click on this link over here in the notes, where it'll take you to some R documentation. Under details, you'll see the different operations that you're able to run on these vectors. You can also filter a vector. So let's see. Let's go ahead and create a new code cell. I'll go ahead and print out vector. And then hit that. You'll see 1, 2, 3, 4, 5. Let's say I want to get everything all the values in the vector that are greater than 3, right? So then what I would do is I would do bracket vec greater than 3. And you'll see it outputs 4 and 5. In other programming languages, there is this thing called a map. It's called a dictionary in Python. And basically what it is, it's key value pairs, right? Where you have a key, like, first, and then a value, 3, or 1, second, 2, third, 3. So you create that in R by simply using a vector over here. So you'll see over here, z equals, and then we're creating a vector, first equals 1, comma, that's what separates one section from another, second equals 2, comma, third equals 213, and so on and so forth. And then you could index the first value by just typing in first, because that is now the index of it. So this is also called a map or a dictionary in other programming languages. And it feels like I'm speeding through this part over here. It is because it's because I am. These are the basics, and I think it's just important that you have a basic understanding of them before we get into like what is actually useful about R for data analysis. And the reason that I do it that way is because oftentimes people will spend a lot of time teaching people all of the basics, which is very much a valid way to go about it. But I find that it's difficult to teach people, to inspire people to learn something, if you're not convincing them that it's going to be useful for them, which is why I want to get to the actual data manipulation as quickly as possible now. You can actually see how this is going to be used. So let us go and talk about matrices now. So if you want to store data in a two-dimensional format, then you can use matrices. These are basically vectors folded on top of themselves and into whatever dimensions you specify, right? So what I can do is I can go ahead and create a new code cell. I can type in mat matrix, and we'll say 1 through 10, n row equals 2. So when I print this out, you will see, it will say, it'll give us a matrix that looks like this. You'll see we have our y indices and our x indices. And then so we've taken the 1 through 10 vector, which is all numbers 1 through 10, are all integers 1 through 10. And then we basically folded it on top of itself twice. If I change this to a 5, for example, then it should fold itself on top of each other 5 times. Basically the exact opposite of what I just did. If you want to access various values inside the vector, inside the matrix, you can use these operations over here, where you'll see we can get the first row by just doing 1 comma blank. You'll see over here, if we do 1 comma blank, we get that entire first row. We get the first column by doing blank comma 1, as you can see over here. So we got 1 and 2. And then you can get a specific value by specifying a column and a row, 1, 1. What you might have noticed is that rows come before columns. So that's just something to remember in your ordering. That's one thing that R does a good job of specifying. It makes it like, it writes out the columns like this instead of saying this is the first, second, third, fourth, fifth column. It writes it saying this is the comma first column, comma second column. That way it's easy to remember. All right, commenting. Commenting is super simple. You may have noticed I've been using these hashes over here to comment. What this basically means is that this isn't code, this is a comment, and R will not run this as code. I recommend, as you're learning, to comment your code very aggressively. There are different schools of thought on how much you should be commenting your code. And in software development, because a lot of kind of algorithms are standardized, like the most efficient way to run things are kind of standardized in a lot of different algorithms. Some people advocate for commenting as little as possible, meaning your code should be so clean that you shouldn't have to comment all that much. I would argue in analytics, it's a little bit different. Commenting is very important because the difference between how you do things, like the amount of times you can do things in a very standardized way, I would say, is fairly limited, which is why I would advocate for commenting, short commenting, as aggressively as you can to start, and then maybe reducing them as you become more experienced. It also helps people who may not be, because the thing is also when you're working in analytics, you'll meet people with different coding skills. And so commenting is a great way to make sure that everyone feels included and everyone's able to read your code. Because I've worked with teams of extremely talented analysts where the coding skills are kind of all over the place. Unlike, for example, a software development team where a certain level of coding knowledge is expected in order to be a software developer. The reason I bring up the comparison with software developers is because a lot of courses out there and a lot of teachers out there, they come at coding for data analysis from a software development perspective. And so I always want to make sure that my people that I teach are aware of what's the difference between software development and data analytics, because coding obviously was created for software developers, not for data people, but then data people picked it up because it was so useful for the work we do. But the work we do is also different. So that's why you'll hear me make a lot of comparisons to software development. All right, so that is commenting, fairly simple. Next, you might have remembered I called this an R Markdown file, and you might be wondering what exactly is Markdown. Markdown is basically a standardized way that people who code will write text that isn't supposed to be read as code. It's not commenting, it's a little bit different. And it's basically used to explain how things work in a data science project. So, for example, you might have noticed that we kept putting in these little R blocks over here. So what happens if I type something here? Well, that's not code. That's written in all the white space over here is a markdown area. So if I copy this over here, I paste it over here, and then I go ahead and I click this knit button over here. So it might need to do some downloading. And if it asks you to download stuff, just allow it to. You'll eventually get this thing to open over here. And what this thing is this thing is a R Markdown file that's been knit together to look like a nice output. It's in an HTML format right now, although you can obviously format it as a PDF if you so want. Where you'll have the coding cell over here, followed by the output. So coding cell, output, coding cell, output, okay? So if we scroll down, you'll notice down at the bottom are all those little things I added just now. So you'll see over here, if I just type in text like I did over here, then we just get text. But you'll see the font is not the same as the font that's used whenever you're writing code. If I write in hash, this is a heading. That's called a single or a header 1 or title sometimes. This is called a header 2 or a subheader. I use a double hash over here. Header 3. I think you can also do 4 for a header 4. This is just regular text. This is bold text. It has 2 asterisks around it. Italic text has only 1 asterisk around it. And bullet points have an asterisk starting them, but not ending them. So you'll see point 1, and then if I tab in, so I hit tab over here, and that, so for example, and if I hit tab, then that's what creates that space over there. That's how you do point 1, point 1, stuff like that. And then numbered points are 1 point, or 1 dot space followed by whatever you want. So for example, I could write in 1 dot, or hello. Here are my points. And then if I hit knit again, then it should just reknit this file over here. And you'll see, here are my points. So this is the reason that this exists, right, is that it allows us to interweave code and explainers between each other and create a file that can be printed and shown to stakeholders and shown to people who actually need our analysis. That way they can read it top to bottom, even if they don't know how to code. You can have text that says, okay, so, here we pull sales data. Here we analyze mean, median, mode. Here we see what are the outliers in our sales data. And you'll write those little blurbs of text in Markdown. And then people will just recognize that, this is code over here. And then you have graphs and stuff like that. So that is, again, not something you'll use right now, most likely, but it is something to remember. And maybe a way you want to intersperse this file when you're following along with me with whatever notes you end up adding in there yourself. All right, so I think... Yeah, okay, so next, let's go ahead and look at just some basic operations. So we're still in the basic R section. I'm going to go ahead and add a new code cell. Let's see. Then let's copy that. Paste it over here. And then let me run it and show you guys what we have over here. So we have... if you have 2 numbers, you can just add them like this. 2 plus 2 equals 4. So you'll see, whoops. You'll see the first value we get is a 4. Add string. So if we do paste of these 2, then it'll kind of like paste them together like this with a space in between and create a single string. Add list. If we just add these lists together, try and figure out how it decided to add these lists together. It's really interesting how it decided to add them together. You can, of course, use subtraction. Multiplication is done with an asterisk, so 3 times 3, done with an asterisk. You could repeat a string multiple times, so 3, comma, the string str. If we go down here, you'll see it just prints out str 3 times. Multiply list. We can do the same thing with the list over here, and you'll see what we get is each value of that list has been multiplied by 3. Div, divide, 2 divided by 2. Modulo, which gives you the remainder of a division operation. So 10 modulo 3 should give you a 1, because 10 divided by 3 is 3 remainder 1. So you'll see that's what we got over here. Floor division, which gives you the largest multiple, which should be 3, basically meaning that 2 goes into 7 3 times, because 2 times 3, or 7 divided by 2 is 3 remainder 1. So instead of giving me the remainder, it'll give me the other part of the value. So you see that we got that 3 over there. And then exponentiation, basically do an exponent. So 7 squared, 7 to the power of 2 is 49. So those are just some like very basic operators we have over there. Fairly simple stuff. Again, we're not going to do much for that today, but it's just important to know how to do basic math inside of R. I have heard. Actually, never mind. I think I'll keep that to right. Or actually, I've heard people describe R as a very fancy calculator. That's not true at all. R is like a floor programming language, or It's not a general purpose programming language, but it is a full programming language. You can do all kinds of stuff with R. Really cool programming language with a lot of cool features in it. Next, we're going to be going over comparison operators, where you'll have 3 double equals 3. Basically, what this says is that 3 is equivalent to 3. We're not assigning, because you can't have a number be a variable. If you remember what I said earlier about like how you could assign variables, you cannot have like 3 be a variable, because then how would you ever assign the variable 3 later? So what this is saying is 3 is equivalent to 3. This is saying 3 is not equivalent to 4, which is also true. This is saying 3 is greater than 4, which is not true. Well, let's see what happens when we actually run these. So we go ahead and delete all those, and then run this, and we get a true. So the logical, this is a remember that logical data type I was talking about earlier? When you have these comparison statements, a logical data type is the thing that's output, basically. So we're asking the computer, hey, is 3 equivalent to 3? And it's saying, yeah, it is. Okay, of course. So then we ask it the question, is 3 equivalent to 4? That's also true. Okay, well then the next question, is 3 equivalent, or is 3 greater than 4? Well, the answer is obviously false, right? So you'll see we get output false over here. Is 3 less than 5? Yes, it is. Is 2 greater than or equal to 2? Yes, it is. Is 4 less than or equal to 4? Yes, it is. Whenever you do greater than or less than or equal to, the equal sign is always on the right-hand side. So, oh, whoops, did not mean to do that. There we go. Let me just make sure this runs properly. There we go. Okay, cool. So you'll see that's what that looks like. And then also you can do ands and ors between logical operators. So if I go ahead and create a new code cell, then what this is saying over here is 3 is equivalent to 3, which is true, and 2 is less than or equal to 5. So what this and is saying over here is if all of the logical operators, if all the comparison operators, my bad. If all the comparison operators are true, then it will output true for and. This is or. If any of the operators, the logical or the comparison operators, are true, it'll also output true. So let's go run this, and you'll see we get true for both. Now let's say I turn this to 0, right? So 2 is no longer less than or equal to 0. You'll see that has no effect on that. But if I was to change this to, let's say, 6, this is now false, because both of these conditions are not true. They both have to be true in order for this to work. So again, this is something we'd be using a lot with like filtering on data, which we're not going to do quite yet. We'll do a little bit later in the course, but just something to remember. All right, so now we're going to go over function. So if you find yourself writing the same bit of code over and over again, then you might want to generalize it into something like a function. Now, what is a function? Now, think about it like a mathematical function, right? Or you know what? Don't even think about it like a mathematical function. Who cares about that stuff, right? What it does is basically you will say insert certain variables here, and I will do some logic to it, and then I will output that logic. So let's take a look at what this actually looks like. So first we're going to give the function a name. I'm going to name my function very creatively, function name. So we're creating a function over here. And then you type in the word function, and then you give it, you type in the arguments that the function will accept. What are the inputs that the function will accept? Let's say X, Y, and Z. And then you use the curly braces, so I hit that. If you're familiar with stuff like JavaScript, this is kind of how it works there too. Curly braces, enter, and then return. The return keyword tells the computer to return, to spit out basically whatever is put in here. And then let's say x times 2, oh, not capital X, sorry. X times 2 plus y plus z. So we created this function over here, right? So now, if I ever want to invoke the function, then I can type in function name, or, well, let's run this over here. I'll create a new cell, just kind of make it very clear. If I ever want to invoke the function, then I type in function name. And then I will, as you can see, the ID is asking me to put in an x, a y, and a z. So let's say I want to do x equals 2, and then y and z both equal 1, right? And then I hit Command Enter, and you see we get 6. Does that make sense? Well, let's go ahead and take x and put it in here. X times 2 is 4, plus 1 is 5, plus 1 is 6. Honestly, this probably would have been easier if I just used one variable. I'm sorry for using 3 variables at once, but for example, if I change this to a 3, then the answer should be 11, right? Sorry, I was thinking about if this was an exponentiation, not that it's a times 2, but yes, 8 makes sense. If I change that, then let's see what there we go. I just had to squeeze them together. Now we get 11. So that's how you create a function. So you can insert whatever you want in here, right? So I can insert a bunch of logic in here. I can be like, I can even like rewrite this by saying something along the lines of like x. So now I've like reassigned what x is, right? And this will like kind of do the same thing. So I can run that. And you'll see we get the exact same value. So this is basically how you create functions inside R. You use return in order to actually return the value that you want to return. All right, next we have control statements. So control statements are basically used to control the execution order of a program based on conditions that you specify. So R has many of the standard control statements you'll see in languages like Python. So let's go ahead and create a new code cell. So here's a really simple one. This is called if else. So let's say x equals 3, y equals 5. If x is equivalent to y, so remember, we're not assigning y to x, we're saying x is equivalent to y. So if they're the same, then x equals y. Else if x is greater than y, print y, x is greater than y. Else, print x is less than y. So basically, we're checking if x is greater than, equal to, or less than y. And you'll notice basically the way we do it is we write an if, followed by a parentheses, which has the condition inside it, followed by a curly brace, which has the action if that condition is true, followed by else if we want to keep extending it, right? Again, then you just follow the same format again. Condition, action if condition is true, and then we have a final else over here. So I can go ahead and run this, and you'll see we print out x is less than y, because x is in fact less than y. If I change this to a 5, then now it says x is equal to y. So that is an if-else statement. Like a lot of things in this video, don't feel bad if you don't get it on the first try. Just keep watching it over and over again. I remember I have had to watch my first, like when I was learning how to code, I had to watch courses like 2 or 3 times to understand them. Like this stuff does not come naturally to people. So don't feel bad if you have to watch this course 2 or 3 times. Almost no one ever gets it on the first viewing. So next you have these things called for loops. So basically what for loops do is that they will take an iterable. An iterable is basically any variable inside R that has multiple values inside it, a vector for example, and it'll iterate through every single one of those values. So we're creating the list. So remember, 3 colon 10 will create a vector that says 3, 4, 5, 6, 7, 8, 9, 10. Let us kind of do this right now. Let us create this and then run that. 3, 4, 5, 6, 7, 8, 9, 10. And then so what this is going to do is it's going to say for I in the list. So for each value in the list, it's going to start off at 3 and then down perform these actions in here, right? So the first value of I is going to be 3. So I equals 3. And then so I plus 2, so now I equals 5, print I. So it'll print at 5. Then it'll go to the next value. I is now going to be set to 4. And so on and so forth. So 4 plus 2 is 6. 5 plus 2 is 7. 6 plus 2 is 8. 8 plus 2 is, yeah, 6 plus 2 is 8. 7 plus 2 is 9. 8 plus 2 is 10. So on and so forth. So that is a for loop. And you can put literally anything you want inside here. So that these curly braces make it really easy to like put stuff inside them if you want. And I believe that R is not sensitive to indentations like that. Yeah, so R is not sensitive to indentations like that the way that Python would be, for example. It's one of the reasons people like Python being sensitive to that stuff is that it makes the language, it forces readability of the language. Remember, code is written or read a lot more than it's written. Actually, that might have been from the Python documentation now that I think about it. Because that's kind of like one of the core tenets of Python code. The code has to be very readable. So that is a for loop. Next, we'll be going over a while loop. So let's go assign x equivalent to 0. And we're gonna say while x is less than 5, x equals x plus 1, print x. So what you'll see is we first set x equal to 0. Then we go down here. While x is less than 5. So currently x is 0, which is less than 5. So we will perform whatever's inside this loop. X now equals x plus 1. So x, excuse me, is equivalent to 1. Print 1. Okay, so now x is 1. Let's run the loop again. X is less than or equal to 5. So 1 is less than or equal to 5. So now x equals 1 plus 1, which is 2. Print that. Go again. So we keep doing that basically until we go to 5, right? So now let's say we are at the value of 4 now, right? So 4 is less than 5. That's true. 4 plus 1, x equals x plus 1. So x equals 4 plus 1. So now x is 5. Print 5. Go over here. Is 5 less than 5? It is not. So this loop no longer will continue. Now, these loops are very dangerous because you can get easily sucked into the trap of an infinite loop, basically. So, for example, if I said z equals x plus 1, print x, then think about what happens, right? If I run this over and over and over again, the x value will basically never stop. So, you'll see it goes on forever, and it doesn't stop. So then you have to cancel, you have to terminate. So there, you saw the stop button over there that I hit. You have to terminate execution, basically. It was an infinite loop. So you want to be very careful that, and if you want to get rid of this output over here, you can just hit X. It'll get rid of that output. So that's something that's very dangerous about, so while loops are very dangerous because of that exact reason. So if you ever create a while loop, make sure that you have written it in such a way that it can never get stuck in an infinite loop because those are just really, really messy. So, and I'm sure there's some use case in which you want an infinite loop. I've never heard of one personally, but just be very, very careful when you want an infinite loop, when you are working with a while loop. Then there's something called a repeat break loop, which I was just introduced to when I started learning R. As far as I know, there's no such thing in Python, where basically it's basically the same thing as a while loop, in my opinion. What it says is repeat this condition in here. If this is true, break, basically meaning stop the loop. So you'll see this the same thing we wrote above there. Or it's similar, actually. For it to be the same thing, we would have to reorder these two operations. And you'll see this is basically the same thing as a while loop. And let me go ahead and hit enter over there just to clean it up a bit. That way you guys get clean code. There we go. Cool. So those are your control statements. This section is heavily inspired by Geeks for Geeks. Again, I mean, there's only so many ways you can teach this kind of stuff. So, go ahead and check out the Geeks for Geeks page if you want like slightly more detailed versions of my explanations. Okay, so we have one more thing to teach when referencing basic R. So let's go down here, create a new code cell. Libraries and installing new libraries. So most programming languages won't have all of the functionality that you'll want right out of the box. To speed up development and move the industry forward, people will freely, for whatever wonderful reason, they will freely create code, very advanced code, that will perform a series of functions for you, and then they'll group it together in something called a package or a library. CRAN, or the Comprehensive R Archive Network, is the official R packages repository. And so packages can do all kinds of things, from like parsing out geographic data to analyzing data for you. Really, there's an infinite number of things you can do with packages, and you'll find that one of the major things that makes coding as a data analyst or a data scientist very different from a software engineer is how much more you'll end up depending on packages to do, how much more you'll find that you're actually kind of working with a very small number of packages really to get everything you need done, versus software engineers who will be working with the base language a lot more oftentimes, because coding is very much a tool for us, whereas like with software developers, coding is like the function of their job. Their job is to design software and to code up that software. Whereas like with, an analyst or something, this is just a tool for us to use, and it's currently the best tool to use. So if you want to install a package, then you just type in install.packages, and then in double quotes, insert the package name up here. We're going to be installing something called Tidyverse. I think it's already installed in my computer, so I probably don't have to, yeah, mine's already installed, so yours will take a little bit longer than that. And then whenever we want to import a package, so once you've installed it in your computer, you need to import it into this R file, right, that we're working with. You go ahead and do library tidyverse, which will, import the value it'll import the library into the file you're working with right now. And this is something that will be a little bit more useful in the future. So let's go ahead and just run that. Oh, and then you'll see R gives us like great little output over here, which talks about like these different conflicts and stuff like that. We're not worried about that at the moment. I can explain these a little bit later, but right now it's not our concern. So we go ahead and put this in here. We can do, what this is saying basically is, you might notice that this is a function from inside a package called dplyr. And so what we're doing over here is we're basically telling it to bring the mutate function specifically from dplyr. And then finally, you can read the documentation for a package by using the little question mark we have over here. So let's create a new R file over here, question mark. Now that we've imported it, you can type in tidyverse. I hit Command Enter, and you'll see down here under Help, it shows the documentation for tidyverse. You can also surround this with, I believe, Help, like that. And then run that, and I think it'll do basically the exact same thing. So just two ways of doing the exact same thing. All right. So congratulations, everyone. You have finished learning basic R. So we kind of spent through that whole section over there. As I mentioned earlier, the whole point of that was to get you like the minimum basics you need in order to actually get you doing stuff in relation to data analytics and data science. If this were a proper, like a full R course, we probably would have spent more time on those basics. But my belief in how you should learn the language is that you learn the absolute minimum you need to know in order to get something done, start doing stuff, and you will be motivated once you see yourself actually doing stuff that matters. And it's one of the criticisms I have of a lot of coding courses, at least when I was growing up. Whenever I took multiple coding courses as a kid, like growing up, and never actually learned how to code. And a lot of that was because they didn't get to a point where we were actually doing useful stuff with the language for a long time, because they spent so much time talking about the fundamentals, which I understand why you would want to do that. You want to make sure people have like very strong fundamentals. But I think with coding, there's also the difficulty of you need to provide people with some reason to continue learning it, especially in today's society where attention span, myself included, just, are going down the drains. But let's go ahead and get on to the tidyverse, which is going to be kind of the crux of data analysis in R for a lot of the work that you do. Not so much data science, but more data analysis stuff. So although R isn't that old of a language, it's based off of S, which has its origins dating back to 1973. And S was a language created at like Bell Labs, this old like American lab that used to just like crank out innovation after innovation. My understanding is they were kind of like the Google of the time when it came to like just innovating all kinds of crazy stuff. And there's some inconsistencies in the language that have emerged since that time. And tidyverse, in the words of the creator of the package on their own website, is an opinionated collection of R packages designed for data science. All packages share an underlying design, philosophy, grammar, and data structures. So let's go ahead and we'll create a new R Markdown file, and we'll call it tidyverse manipulations.rmd. So I'm going to go to Files over here, and then I will click here, R Markdown, and then we'll call it tidyverse underscore manipulations.rmd. Hit enter twice, and then we'll add a little R block in there. I'm going to save this, kind of Command S, Control S if you're on Windows. Yeah, and let's go ahead and get started with the R. With the tidyverse. So we can install the tidyverse through this code. We've already done that, so actually I'm going to remove that over there. Whoops, so let us get rid of that. So let's go ahead and import the tidyverse. There we go. Cool. All right, so, like I'm saying over here, congratulations, you finished all the preliminary work to understand R. As a data analyst, I have had to know how to do all my work using the functions above, but I typically apply tibbles more directly to my work, or the Python equivalent, which are pandas data frames. This is where the meat and potatoes of data analysis inside R lies, basically. Data frames are basically a data structure that organize data into a 2D table of rows and columns. Think of an Excel spreadsheet, so not the workbook, but the spreadsheet, those individual sheets inside Excel, basically. So tables are improved versions of data frames with features that force you to deal with problems in your data earlier on. So they won't try. There's a lot of kind of baggage that so R has a data. Excuse me. R has a data.frame like kind of package inbuilt inside it, which handles two-dimensional data quite well. But it comes with a lot of assumptions and stuff that doesn't work really well with modern data analysis, which is why tables were created. So data frames are more commonly formatted as data.frame, R has a default data frame, which are more commonly formatted as data.frame. And if you want to convert a data.frame into a tibble, then you can use this as tibble, and then you insert the data.frame in here. Because I believe you will more likely going into the future encounter tibbles than data.frames, I'm going to only use tibbles in this course. But here are a couple of lines of code you might want to just have handy with you of converting, converting tibbles to data frames and data frames to tibbles. And the reason you might want that is some functions only work with data.frames and some functions only work with tibbles. It's one of the things you'll notice about R. There is a lot of fragmentation in the packages in the language, which is a bit of a difficulty to handle sometimes, but it is getting significantly better, especially with the people at RStudio and the people who handle the tidyverse helping out. So if you want to have a little bit of fun, go to the tidyverse website, and you'll see all kinds of just like great graphics and stuff, kind of telling you how the packages work. So let's go ahead and create our first tibble. So I'm going to create a couple of vectors like so. So we're going to create a vector x, which is just 1 through 5. We'll create one y, which is basically we'll create it as just 5 random characters. And then we'll create z, which will be, I don't know, we'll just do 6 through 11. I believe that's 5 characters. And then we'll create our first tibble. So we'll type in first tibble. Has 2 L's instead, or 2 B's inside it, 1 L. And that is equal to Tibble X, Y, Z. First Tibble. So let's go ahead and run that. So I believe I may, let's see, 1, 2, 3, 4, 5. Let's check. Oh, you know what? This needs to be 10, I think. There we go. So when I had 6 through 11, so that's 6, 7, 8, 9, 10, 11. That's actually 6 characters. So when you create a tibble, like all these vectors have to be the same length. So I need to be 6 through 10, not 6 through 11. So because R includes the two values on either end of your vector. And you'll see we've created this tibble over here where X is 1 through 5, Y is 2, 3, 5, 1, 5, Z is 6, 7, 8, 9, 10. And yeah, and then that's our tibble. So we created our own data over here, but oftentimes you'll actually be reading in data from various file formats. SQL is a really popular format to read data in from. Obviously, the way you connect to SQL changes from database to database, so we'll not be going over that today, especially because that also assumes you already know SQL, which may or may not be true for people doing this course. So we'll stick with another extremely common format of importing data into your data frames, and that is the CSV, or comma separated values. So if you remember this data folder that we downloaded from the Google Drive earlier, that has a couple of CSVs inside here. So you see like Netflix. There's a couple of Netflix files in there. So let's go up one level. But first, let's go ahead and just import a really simple CSV format. One thing to note is that you'll use the read underscore star, so CSV, Excel, whatever, method of the tidyverse libraries in order to actually read in your data. And reader is the library inside tidyverse. So tidyverse is actually a collection of libraries, and reader's inside tidyverse. Reader is faster and it's more standardized. It's a faster, more standardized way to read common file types using R. There is a base. Whenever I say base, I mean it's included with the R language. So a base read.csv, which inherits behavior from your operating system and might behave differently from your computer versus someone else's, which is why you just want to use the tidyverse version of it. And if you work with Python inside pandas inside Python, you'll know that the behavior changes slightly between a Windows and a Unix-based computer, which is one thing I actually kind of like about tidyverse versus pandas, for example. So we've already imported the tidyverse, so we don't have to import it again. Let's go ahead and create a string, or a set of characters, basically, for our file path, right? So the file we're currently in, tidyverse underscore manipulations.rmd, as you can also see over here, that's the file we're in right now, is located in this directory, wherever you ended up putting it. And we need to go into data, and then from data, we need to pick up simple underscore csv.csv. So what I'm going to do is I'm going to create a variable called file path. And then I'm going to put in double quotes, data, because we need to go to the data folder, / simple underscore csv.csv. And this / over here should work on Mac and Windows. I tested it out on my Windows computer and it seems to work just as well as it would on Mac. And then we're going to create a variable called first import. So first import, and that's going to equal read underscore CSV, and we're going to read the file path. Then I'm going to print out first import. And you'll see what it did is it went ahead and read this simple CSV file. If you click on it, you'll see they look the exact same, except this is formatted nicer. It's one of the things about Tibbles, they format very nicely. So it's just a bunch of random data. It doesn't mean anything. It was just to demonstrate some like super basic operations. So while reading in the file, we get something called a column specification. That's what these things are over here, which is the name of the column and the variable type that the Tibble imported it in as. If you want to read Excel files or other data types, here's a cheat sheet, another one from the wonderful folks at R Studio. So I can click on that, and it'll give you a bunch of information on reading, like, CSVs, TSVs, all kinds of other files. Excel files are kind of difficult. Oh, here's read Excel as well. One thing to know as well is that Excel files, I don't recommend storing data in an Excel file if you can avoid it, because Excel will do a lot of autocorrecting with your data, which may delete rows and stuff that you may not want to delete it in your file. I would also avoid opening up CSVs inside Excel unless you open them up in a very special way, which I have an Excel course that you can watch where I teach you how to do that. But I would mostly avoid using Excel files if you can do so, because there's all kinds of just weird stuff that Excel does that makes sense in the world of Excel. But if you're purely just trying to save data, it's not the best format to save data. And in my opinion, CSVs are a lot better because, provided they're formatted correctly, there's basically no way to corrupt them. They just, exist. So let's go ahead and start working on some columns. So we have, this is one thing you can also call like vectorized data, meaning that each of these columns it represents like a vector of data. And the reason that we call it that is because it allows us to perform vector operations on our data much more quickly. So like anything that requires an entire column to do, like summing an entire column, mean, median, mode of a column, individual or like max and minimum of a column, that stuff works really fast in these types of data sets. So looking at the first import variable we've created, let's see if we can perform some very basic transformations on it. So let's say that I only want to extract the first column out of the out of the tibble, right? There's a couple of ways we can do that. You can put in first import the name of the data frame or the name of the tibble. And I'll be using data frame and tibble interchangeably. When I say data frame, I'm not going to ever refer to data.frame in this course. If I do, then I will be very specific that I am. I'll say data.frame. So we can get the first column by using this $sign. So tibble, the name of the tibble, $, and then the name of the column. You can also do the name of the tibble, double bracket, the name of the column. And then you can also do double bracket and get the number of the column as well. So those are a couple of things you can do to extract a single column. So you'll see it kind of just prints them all out as like a single vector. Like I said, vectorized operations. So another thing you can do, a couple of other operations. Let's say you want to create a new column, right? So we can do first import, and then we can, whatever method you want to use. I'm using the $sign over here. We specify the name of the new column. And then let's say we want every value in that new column to be the exact same. That's where we just assign it to 1. And basically, if we do this, you'll see a new column was added where every value is just 1. Another thing we can do is that we can create a new column, and then we can assign it individual values, right? So what am I doing over here? I am creating a vector 1 through 29. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to 29. And because there are 29 values in this data frame, it will have a new value for each row. So you'll see over here, if I go down here, 1 through 10 of 29 rows. So if I run this, then you'll notice 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way through 29 over here. Now that's what our new column is. Basically, I've overwritten this one with this one. Then you can do other, oh, sorry about that. I'm not used to, this mouse isn't scrolling the way I'm used to. Then you can do let's say we want to create a data frame or we want to create a column called adding stuff. And one thing to note in R, you basically never want to have spaces in your column names. I'll show you why that's a problem a little bit later. So let me go fix this documentation as well. So let's say we create a column called adding underscore stuff, and first underscore, what it'll be is it'll be column 3 plus column 1. So the values in column 3 plus the values in column 1. So if I run it, then you'll see adding stuff is this over here. And if you, let's see, we said column 3 plus column 1, right? If you add this and this together, you'll see it should basically add up to 0.28. Yeah, you see it's 0.97, whatever. So you'll see it basically adds up to that as well. So that's, we're adding together columns, right? So I can even do minus, and it'll just subtract the columns from each other. So if I run that, then you'll see we get a couple of negative values over here, basically whenever column 1 is greater than column 3. What we can also do is we can drop a column. So let's say we want to drop or basically delete column number 2. Then if we run this, you'll see column number two no longer exists. So basically, we did first import, and first import now equals select. So we're selecting columns. We put in first import over here, minus column 2. And what we're doing over here with select, if you're familiar with SQL, you'll understand where the select syntax comes from. If you're so interested, I also have a SQL course you can check out. Hopefully I link it somewhere over here. Okay. So let's do a couple of other operations, right? Let's say you get a, so first of all, let's bring in our new data set, right? That way we can start illustrating with some real data. Okay, so R, and then I'm going to create a new cell, and we're going to import that Netflix data. So data/Netflix titles.csv. And when I run this, you'll see we got a data frame with 7,700 rows and 12 columns. Remember, in R, rows come before columns. So what if I want to know all the column names in that data set? And let me give a little bit of a primer on this data set. So this is some data I pulled from Kaggle. It's from Shivam Bansal, who put it up on Kaggle under this link over here. So be sure to check out their work and like their work as well, to give them some props for all the great work that they did to keep this data set up. I think basically it lists all the titles in Netflix. I'm not sure which region of Netflix, but just in Netflix. So let's say we wanted to just list out all the columns, right? Because as you can obviously see, we can't see all of them over here. I can go here, create a new one. I can just type in column names, I believe, and then do Netflix, and you'll see it creates a vector where we just list all the different columns that we have. And this is 4 by 3, so this is the 12 columns that are in that data. Now let's say we want to perform some basic descriptive statistics on this data. Now we're going to use the actual data analysis work that we'll be doing. So let's go to perform some basic descriptive stats on this. You'll see that it's as simple as creating a new R code block and then just writing summary Netflix and then running that. And again, I'm just hitting Command Enter or Control Enter on Windows. And you'll see for characters, it just, gives you a couple of basic values. But whenever you have a numerical field like release year, you'll see it'll give you what's the minimum release year, the first quartile, the median, mean, third quartile, max. So you'll see this data is updated as of 2021, for example. So cool, we performed some basic descriptive statistics on our data set already. And you can see how fast it was, right? It was literally just summary data set. Simple as that. And then once you get really good at, once you memorize these commands, it becomes really easy to just do a quick analysis of the data set and, see how a couple of stuff operates very, very quickly. Let's say you want to see the unique values in column. And you might be wondering why we're going through these values, or we're going through these exercises one after another. The reason we're going through these exercises one after another is because this is kind of like the standardized template I use to analyze a lot of data sets. I'll import it, I'll look at all the column names, I'll run some descriptive stats, I'll look at each of the columns, see what the unique values are inside them, stuff like that. So this is what I do as a senior data analyst, to just go through data really quickly and understand what's inside it. So let's create a new code block, and then we'll type in unique, and then we need to reference a single column, right? So we can do Netflix, and then there's multiple ways to do it. The way I did the double bracket method inside my Notion notes, but over here, I will just do type, and you can see that I didn't even have to list out I didn't even have to put it inside double quotes. I can if I want to, but I don't have to. And it looks like inside the type column, there's only TV show and movie. That's it. Those are the only two values inside that column. So now, a really common thing you might want to do is split columns. So let's go ahead and just look at the date added column. So let's go ahead and create a new R thing, Netflix, and then I think we just do $ date added. So you'll see the date added column is listed kind of like this, right? Let's say I wanted to get the year added. What year was this movie or TV show added to Netflix? Well, that's basically this, I was about to say $, this year at the end of each date, which is separated by this comma and this space over here, which is what we call a delimiter. So a delimiter is basically what separates each chunk inside a collection, or kind of like, it's the thing that separates each item in a line of items, kind of. So in a CSV, a comma-separated values file, as we see over here, or maybe this is probably better. As you can see over here, the delimiter is just a comma. And you can see it's not a comma followed by a space, because that would actually change. Then the delimiter would be a comma plus a space. So there's no space. It's just a comma. Basically, a comma separates each value, and a new line separates each entry from one another. So I'm going to make sure I don't say that. So what I want to do is I want to, in order to get this year over here, I want to split this column based on that comma space attribute, right? So let's go ahead and do that. We can do that using the, I'm just going to copy and paste this and explain it. That's a bit long, so let's, oh, one thing you can, I think, can I just do it like this? Or do I have to do it like, there we go. So you can surround things with head, and that'll just give you the top 6 values, I guess, in this case, instead of giving you like a bunch of them. So that's one way to just limit the number of values you get. Oh, whoops. I thought I copied this. Copy. So we're creating a new column called year added. Let me just delete this for a second so we can read this all in one line. And what we're doing over here is we're bringing in the string split method, Netflix. So we're getting the Netflix date added column. Again, remember these double brackets are just another way of calling a column. We're specifying that the delimiter is this comma followed by a space. Simplify equals true will output a matrix, and we want to get the second value in that matrix. So let me go ahead and just show you what this actually looks like. So string split, and if I run this, you'll see what we get is we get a, oh, and then let me get rid of this for a second. So I commented it out, as you can see over there. So this is what we get, right? Because we're taking the Netflix date added column, we're splitting it on this comma space. So you'll see there's no extra space over here. Simplify equals true. What that does is that creates a matrix of every single row. So August 14th, 2020. If I had simplified equal false, then you'll see what it does. It creates this confusing vector, this like double nested vector that we have to parse through. Basically, you generally will want simplified equal true. And then what I'm doing over here is, remember in our matrices, excuse me, we want to only bring the second column worth of stuff, right? So this is how we bring in only the second column worth of stuff, because that's where all the years are, right? Down here. So we'll run that, and we get a vector of every single year. And then remember up here how we basically assigned a vector of values to a new column. That's what we're doing. And I'll explain one more concept over here real fast after I kind of just show you the end result of this. So go ahead and copy that code again. So Netflix year added, the column year added, is going to equal string underscore split. Netflix date added, simplify equals true Netflix. So let's go ahead and run that. And then you'll see if I go all the way to the end, we have our year added value. So let's say you might be wondering, like, hey, Shashank, what's this? Like, this is random string split thing you brought in, right? So you'll see if I type in string split, right? You'll see it says stringer over here. This is the library that it comes from, right? So let's say you find, let's say you didn't know about this function, right? This function exists inside um, Tidyverse, and you didn't know about it, but like you know that Tidyverse has a lot of functions to clean up data and stuff, right? How would we actually find out about this? Well, we would open up our web browser, and then we type in something along the lines of split string tidyverse, and then you'll see, it'll usually be the first result. The stringer documentation pops up with the string split method over here, and it says, and it gives you what goes into each section. Remember when we created that function, every argument had a space, the X, the Y, the Z. Same thing over here. String pattern, N is basically the number of splits you want. I didn't have to specify it in this case. And then simplify what that does. And then you'll see down here, arguments. It tells you what each argument actually does. So this is how you actually, research new functions whenever you do this. And kind of the point of this whole exercise, right, is that this whole course is to get you to a place where you start looking up this stuff on your own as you encounter new things you have to do. Because it would be basically impossible for me to, it would be a 5-hour or like a 10-hour course or something. I don't know, like, and no shade at all. They have these like 10-hour courses on YouTube and stuff, which I debate how useful that is because I'll put it this way. Those 10-hour courses where they teach you basically everything about like data cleaning, even I probably don't know some of the functions inside Python, even though I've been coding in Python for years at this point. And that's because I usually just look up new functions as I need them. That's kind of the way that a lot of people learn how to use stuff in this space. No one actually knows almost no one actually knows all of the functions unless you super specialize in like a single thing. I learn stuff as I need to, which makes it easy to make sure that my skills are both sharp because I'm constantly learning, but probably more importantly that I know what I need to. There is a such thing as being, or as having a specialization that like isn't particularly lucrative to you or particularly useful to you, and you generally want to avoid that. Okay, so now that we've taught you guys how that works, another thing you might want to do is you might want to rename a column. So I'm going to go ahead and copy this, create a new R block, and we'll reassign our Netflix data frame. We'll say dplyr colon rename. Remember what this means? This means that get the rename function or method from the dplyr package specifically. And the reason we're doing this is because in older versions of Tidyverse, there was this thing called plyr, or maybe not Tidyverse, but basically there's a package that used to be called plyr, which had its own rename function inside it. And by doing this, we're telling make sure to get the rename function from the dplyr package specifically. So we're going to rename, and then it asks us to put a data frame inside it. We're going to take the column year underscore added and rename it to year. You might be wondering what these little backticks in here are for. These backticks are used to, let's say you have a column that has a space inside it like that. This is how you need to reference it if you want to reference it in R. You need to use backticks. You cannot use double quotes or single quotes. In an earlier version of this course, I actually had a space in there. I just removed it because they're such a pain to deal with in R that it wasn't worth it, and it's just good for you to know that the backticks mean if a column has a space inside it, that's how you reference it. So we're going to take the year column and we're going to take the year added and rename it to year. Oh, you know what? Sorry. In order for that to work, you know what? Let me just do it this way. Netflix year added equals, okay, cool. So we'll do that. And then, oh, did I? Huh, I must have done something on accident. Let me just create a new column then. And then we'll have this year added in here like it was earlier. Oh, okay. So yeah, I messed up and accidentally duplicated the column. So what I'm going to do is I'm going to roll back my changes by basically. Okay, so we have year added over here. Okay, so what I'm going to do is I'm just going to rerun all that code again. So we're just going to re-import that Netflix file. And then, these don't actually do anything. That just lists out column names. That just gives us our descriptive stats. We're going to create year space added over here. And then if we go all the way to the end, you'll see we have year space added. And then we're going to add a space over here and then run this. And then now it's been renamed to year. So I'll make sure to fix this inside the notes as well. That way there's no confusion. But basically, I ran the same code over and over again a couple of times. And if you remember, each time we add something, each time we assign a value to this, assign a data frame or a tibble to this Netflix variable over here, it changes it slightly. So you have to make sure that your changes are done in order. Usually what you'll end up doing, and I'll show you a little bit later, is you'll use these things called pipes, which are a great way to chain a bunch of operations one after another. And it's a really cool innovation in R that I don't believe we have in Python, but pipes are super cool. So I'll show you how those work in a second. So you might be wondering, okay, how do you deal with null values? There's this thing called fill NA. So what are null values? Null values basically mean that data is not present inside this area of the data frame, right? It's not the same thing as a zero. It means data is not present, which is, not the same thing as a zero. Oftentimes you'll find NA data in your data frame, and you often don't want this in your data. And the reason you don't want this in your data is a lot of machine learning algorithms, a lot of statistics don't really work if you have null values, or there are so many null values that you need to do something about it in order for your data to actually mean anything, which is why you have to know how to deal with null values. So in the cast column, the column called cast, we have a couple of null values, right? And we can deal with them with this replace NA function. We'll put in Netflix cast, the cast column, and then we'll replace it with the value no cast. So before I run that, let me go ahead and show you what Netflix looks like right now. Or, well, I guess we have it from our previous renaming function, right? So I can just go back here to wherever cast is, and you'll see on the second page, there's an NA over here. You'll notice it's a different font, it's colored differently and everything. This is R trying to point out to us that, hey, this is like different. So this is an example of a missing value. I want to replace this with no cast, like the words no cast, right? So let's go ahead and run this. And you'll see, when I go to cast now, go to the second page, you'll see now it says no cast over here. And that's one way to deal with null values. All right, let's get back to it. Let's try working on some rows right now. So we did a bunch of column operations. Let's work on some row operations. I'm going to go ahead and add in a new R block. And then let's say we want to bring in, let's say we want to select the first row, right? We can use the slice operator. So I type in slice, and you'll see it asks for dot data. So I put in the data over there. And then if I want to select the first row, then I just put in a 1. And it selects the first row. If I want to select the first through the 10th rows, I do that, and it selects the first, the first through the 10th row, the first through the 10th rows. So easy enough. Now you may have remembered I mentioned something called pipes earlier in this video. So pipes are part of the magritter package. There's some inside joke about it that goes beyond my intelligence, but when it'll usually get imported with tidyverse, and you'll recognize them as these percentage sign greater than percentage sign little chunks of code. And basically what a pipe does is it allows you to chain operations together one after another. And if you're interested in the history of pipes behind R, check out this little blog post by Datacamp over here. I found it very informative on the subject. So when piping an input to the next stage of a pipe, you can use the dot to tell R where in the next function you want to input the previous value like so. So first, let me show you what the pipe actually does. So let's go ahead and take one of our old... Let's go... Oh, you know what? Here we go. This is perfect. So we can just take this over here, right? So what I can do... or actually, let me go back up here for a second. Let me copy the whole thing. Let's say I wanted to rewrite this little chunk of code over here to actually only use the to use pipes instead, right? So what I would do over here is let's see, I would replace this with a pipe. So then what happens is this Netflix cast is going to be input over here, and then I could get rid of this. And by doing that, what happens is it's going to actually input the data from here into the first argument of this function over here. Or I can directly specify by just putting in a dot and then of course just a comma over there. And you'll see it does the exact same thing. Now, obviously it's acting it on this single row over here, which is not precisely what we wanted. So let me go ahead and get rid of that. So a better example of it would be, this is kind of like the generalized version that we take the data frame, function that does stuff, next parameter, hello. So what we really want to use this on is we want to use this on full data frames, not on single columns. So actually, maybe there's a better example up here somewhere. Yeah, I guess this would work. Now, of course, we can't rename this because the column's already been renamed, but I could replace this over here and then remove this over here. And this would be an example of using a pipe. Obviously, on one operation, it doesn't make any sense, but you could have operations chained one after another, in which case it'll make more sense. And I'll show you how this works in a second with some chained operations. One thing to note, though, starting in version 4.1, R released, the version 4.1 of R, which was released in the mid-2021s, pipes were included in the base language, so they're no longer only a part of the magritter package, and they're formatted as this thing. So the funny thing is that that's actually called a pipe. So pipe greater than. Honestly, it'll probably take a couple of years for this pipe to gain mainstream adoption in like just code you see everywhere. So I would continue to use the magritter approach until you just start to see this one adopted everywhere. Yeah. And one thing is, this one also doesn't allow for the dot functionality that magritter does. Again, depending on your team and what you see written over, like in your team, maybe your team's a little bit ahead of the curve, maybe your team's a little bit behind the curve. I would suggest pushing to adopt this, but don't be worried if you have to use this for now. At the end of the day, I think it's luckily a minor change for many operations. It's not this isn't a drop-in replacement. A drop-in replacement means you can just use it as is and it'll work just fine. But it'll work in many cases where it needs to. Okay, so let's go ahead and use the pipes for something useful. Like let's say we want to filter our data. So let's say we wanted to bring get our data frame such that we only get the country Singapore, like movies made in Singapore or TV shows made in Singapore, right? So what we would do is we'd take a Netflix, we would pipe to the next function, which would be filter, and then we want the country to equal Singapore. And you'll see what happens over here. We only have 23 rows of data. And if I go to country, everything says Singapore. So that is a good use of the pipe operator. So we can also have multiple conditions if we want. So let me go down here. And you'll see what we did is in one set of parentheses, we say we want the country to equal Singapore. And remember this and operator over here? We want the rating to be TBMA. So country equals Singapore, rating equals TBMA. So that is we're further limiting our data. And you'll see this only brings in 13 columns. Or sorry, 5 rows, my bad. 5 rows, but 13 columns. And there's only 5, and you'll see the country equals Singapore, and the rating does, in fact, equal MA. All right, so as a data analyst, dates and times are going to be one of the most challenging data types that you encounter. Different systems will store them differently, and there will often be different formats of dates in the same database. And then, if you work with an international team, and when I say international, when you work with America plus any other country, then you'll get the whole mix-up of like days and months. Where in America we do what, month, day, year, whereas literally the entire world does day, month, year, which quite frankly makes a lot more sense. I get the logic of the American method in that like you want to know the month first, miss sometimes, then the day, and the year is not too relevant. I don't know. I think we're just different sometimes. Either way, you'll know that dates are some of the hardest things to deal with in analytics, like from a data cleaning perspective. So R uses the LubraDate package, which is also included inside Tidyverse, to help ease the burden of dealing with dates. And when you're dealing with dates, you're usually dealing with either dates, times, or date times. And then also something called a timestamp, which is basically a date time with a time zone attached to it as well. One thing to keep clear, one thing to remember as well. So I don't believe I have to actually import the LubraDate package. Let me try doing it without importing the LubraDate package. Actually, does this work in? Okay, it doesn't. So we're going to do Netflix, and we're going to pipe in mutate. Mutate is used to manipulate columns, add, subtract values from them, stuff like that. So, and then, of course, if we want to know exactly what it does, right? How do we do that? We do, question mark, mutate. Create, modify, and delete columns. That's exactly what mutate does. Okay, so I am running this chunk of code over here. Oh, there is not a column called computer date. I think this actually is date added. Oh, okay, so we actually do have to import LubraDate in that case. Okay. We need to import LubraDate. There we go. So you'll see date added. If you remember earlier, it said like August 14th, 2020. Now it is written in the standard data, what I call the database format, which is year-month-day, 4 digits, 2 digits, 2 digits. So you'll see there's like a leading 0 over here. In my opinion, this is the best way to write dates down. Because you can also sort dates based on like a string sort in case this isn't saved as a date type or whatever package you're using doesn't support dates for whatever reason. So you'll see this is now a date type. So we do have to import the LubraDate package, and then you'll see what we did is we used the Netflix data frame, we piped it into the mutate column, mutate function, and then we said date added. So the date added column should equal MDY. MDY was imported from LubraDate. MDY date added. What MDY says, it says the string you're about to receive is in the month, day, year format. And if you remember, if we go back to our files over here, and I open up Netflix, let's see if this opens up. There we go. Oh, it's a little bit hard to read this one. Let me go ahead and open it up separately. So I just hit the space bar on a Mac, which opens up this like nice little view that you can see it in. If you remember, the date added column was originally in this format over here, month, day, year. So by doing MDY, this is a function in Lubridate that allows us to bring in the date added. So something cool for you guys to ponder on. And you can go inside the Lubridate. If you go down here, there is a cheat sheet which has a lot of other functions that you can follow. This is just this is the cheat sheet. And what I would recommend, I would recommend even like straight up printing out these cheat sheets and literally having them on your desk. They're extremely helpful. And if you memorize all the cheat sheets, you'll probably actually will know all the basics about data manipulation inside of R. So let me just go ahead and change this to date added. That way there is no confusion here. There we go. So one thing to remember, or one thing that we may have run into, we actually ended up with a couple of NA values. Let's say we want to fill those in, right? We'll have to create a date time variable using the replace NA and make date modules. So what happens is, if I didn't use this make date, if you remember replace NA, right, from earlier, it would take any of the null values and replace it with whatever we told it to replace it with. If I don't use this make date over here, and I was, for example, to just write 2021, 01, it would think that this is a string and try and replace it with a string. That's why we need to replace it with make date and then specify year, month, day. That way it actually replaces the value with a date value. So if I go ahead and do that, then it'll go into the date added column and replace any null values with the 1st of 2020. So for example, one cool thing, I can go click on this Netflix thing over here in the variable explorer, and I click the play button. And you see I have this nice view that I can look through. I can even sort it over here. And if I go all the way down, you can see it's kind of slow to load sometimes. So 2020 is probably like around here. Maybe a little bit further. 2019, we're almost there. 2019, almost there. You see all these 2020 0101s? A lot of those were probably the null values that we just replaced. So, and if you want, you could rerun the operation again. Import the file, look at it first, and then rerun the operation. You can probably see the actual difference yourself. All right, so those are dates. Next, I want to go through group bys, aggregations, and sorting values. So these are very valuable operations where you group data into different sections, and then you can aggregate it separately. Like you can sum it, you can count it, stuff like that. So I'm going to hit R over here. I'm going to add this. So Netflix, we're going to group by country, and I want to summarize. We're using the British version. I wonder, can you use the American version? Oh, yeah, I guess you can. Okay. So you can probably use the British or the American version. And then I want to create a column called count. So basically what I'm doing over here is I'm telling it to take the Netflix data frame, group by the column country, as you can see over here. Of course, some of the movies are made in multiple countries. So, and then summarize, create a column called count, where we take the n distinct, which basically means the distinct count of show ID. And show ID is a unique key inside this data frame. Every single row has a unique show ID. So basically, we're counting the number of, the amount of media made per country. And you'll see we have this count over here. And then let's say we wanted to do something a little bit further with it. And this is where we can chain operations together, right? So we're going to create a new data frame, see, where we take Netflix. We're going to create a new data frame where we take Netflix, group by country, and then summarize by count equals n distinct of a show ID. And then arrange basically resorts the value, so it'll sort them in whatever order you specify, in descending order by count. That way we can see which countries made the most movies. It's probably going to be the United States and India, quite honestly. Yep, United States followed by India, followed by NA. So we have a lot of null values in our country column, as you can see. So 2555 US, 923 India, and then so on and so forth. So that is how you aggregate values inside R. Now, let's say we wanted to find more aggregations to do over here, right? Like n distinct is cool and all, but let's say we want to do more. Remember that technique I showed you guys? So let's create a new, and I'm just type in n underscore distinct, and you can see it comes from dplyr. So what I would type in to see what other aggregations I can do, I can probably type in dplyr aggregations and Dave Tang's blog. Let's see what Dave Tang over here has to show us. So you can see maybe not this one. Okay, here we go. Yes. Oh, and it looks like you use summarize or summarize. Here it is. A list of functions that you can summarize on. So something to keep in mind. So actually, I'll even link that over here for you guys. So we'll say under use, or it's not really code, under useful functions, there are a list of functions you can summarize on, like a type today. There we go. And then, as per usual, I provide a little cheat sheet, courtesy of RStudio, obviously I didn't make the cheat sheet, where you probably have more of these functions all around. So there's just like different stuff you can do with the dplyr package. All right, so now we're going to go through joins and unions. So oftentimes you'll want to enrich your data by adding more data sets to it. So for example, you can do things like joins and unions. Long story short, unions are when you take your data and you stack it on top of each other. So you add data, I guess, vertically in this case. And then joins are when you enrich your data by adding it horizontally. So there's maybe some, some data over here that you want to add to this data set over here, and then you just join it horizontally. Let's go over how it actually works in using a couple of examples from my Tableau course, which is also probably linked over here by now. So, okay, put simply, a union, which comes from SQL union, is the process of stacking two tables on top of one another. And you'll usually do this when your data split up into multiple sections, like an Excel spreadsheet of a year sales split by month, for example. So let's capitalize Excel. So you'll see over here we have a table where it says style, color, model, and a table where it says style, color, model, and then car. There we go. And basically I'm unioning them, so I stack them one on top of another. And I should have bolded this top column over, this top row over here. But you'll see big, small, medium, puny. So big, small, medium, puny. But you'll notice that the car is not a it's not a variable. It's not a column in this data set over here. So these two values are just null. That's basically what a union is. You're just stacking data sets on top of one another. So you might have noticed earlier that we have two Netflix data sets in here, Netflix title and Netflix title second. Well, those are actually continuations of each other. So let's see if we can stack them one on top of another. So what we're going to do is we're going to re-import Netflix titles.csv because we did a couple of additions to it. We added some columns and stuff, so we want to re-import it for a clean version of the data set. And then we want to bring in second data set, read_csv, data/Netflix title second.csv. Then we're going to create a new data set, and we're going to be using the rbind function on Netflix reimport over here, and second data set over here to create a new data set. And if you remember, the Netflix data set, I can go ahead and put it over here, Netflix. It is something like 7,700 rows long. Yeah, 87 rows long. So this should be a lot longer then. So we're going to import these. And you'll see it's 8,100 rows long instead of 7,700 rows long. So that is a union. Joins are a little bit more complicated. What they do is that they combine two tables horizontally. For a join, like a union, you have to have at least two tables. One will be called the left table and one will be called the right table. You mostly have to have at least one matching column between the two tables. There is one join which you don't need a matching column at all. That's called a cross join. And the most common way to visualize types of joins are through Venn diagrams, right? So there's four types of joins that you can have. So let's say you have a left table that looks like this and a right table that looks like this. So the left table has a column called ID, color, and model. And the right table has a column called ID and car. Now, obviously, we're going to be joining on these ID columns over here, right? So the four basic joins that you can see, or that you can use, are the inner join, the left join, the right join, and the full join. So an inner join basically will take, based on whatever column you specify, right? In this case, it would be the ID column over here, right? It'll combine the two data sets and drop any rows where there isn't a perfect match in the ID column from both tables. A left join will take every single value on the left table, but only bring in the values from the right table, which match the values on the left table in whatever column you specify. A right join is the exact opposite of that. And then a full join will bring everything and combine the columns where they match and then put nulls everywhere else, but it'll keep all of your data. And we'll go over this in a second, don't worry about it. You'll mostly be sticking to left and inner joins. It's worth your time to learn more about joins because they're some of the most powerful tools you can use to manipulate data. And I use joins basically every single day to enrich data. So for example, you'll have like an HR table in one SQL database or one CSV, and you'll have like pay information in like a different CSV, and you need to combine them. You combine them using a join. So a left join, yes, so this is an inner join over here. So you'll see when we combine these two tables over here, the inner join only keeps that first row where the ID equals 1 because that's the only common row between them. That's an inner join. It's the intersection of the two. A left join will keep all the values. So you'll see this is the final table over here. A left join will keep all the values from the left-hand side, but only the one value from the right-hand side that matches one of the left-hand side values. So you'll see we end up with two null values over here because ID3, which shows up in the left table, does not exist in the right table. A right join does the exact opposite of that. And then a full join will bring in everything. So we have, because we have 1, 2, 3 different IDs, we'll have 3 different rows. And you'll see null values are basically put in wherever we don't have any values to join on. Now, one thing to remember is joins can be a little bit tricky because there is the potential for gotchas when joining two tables. The most common one is called a row duplication, where you accidentally duplicate rows because the columns you're matching on have multiple potential matches. In the example below, you're going to try an inner join, and you'll notice columns in orange were duplicated. So let's change our right table to have ID 1 on both rows, right? Now, if you do a left or an inner join, in this case, we're doing an inner join, you'll see we have to actually duplicate row 1 because you're matching every 1 with every 1 in both tables, like every ID 1 in both tables. And this isn't an error per se. Sometimes this is exactly what you want to happen, but it's something you should watch out for because you can occasionally add more rows to your data when you don't intend to. I believe these are the exact same. Okay, so let's get rid of this one then. I think I just duplicated it on accident. So let's say we want to combine our tables, right? So let me go ahead and create a new R block. And remember that Netflix movies by country data frame that we created? Where we had every country and then we had the number of movies per country. let's say we want to add that to our Netflix re-import data. This is data that didn't exist in the original table that we created, and we now want to add to the original table. Well, we'll create a new table. We'll call it Netflix merged, and we'll use the inner join, excuse me, the inner join function. The first argument will be Netflix re-import. The second will be Netflix movies by country, and then we'll tell it to join by country. And then if I run that, then you'll see at the end over here, we have our count variable. And of course, this is a very simple example, but this is one of the most powerful techniques in data analysis. Like you're combining a bunch of data that wasn't normally together, and putting them together. That way, you can do all kinds of you can find all kinds of valuable insights from your multiple data sets combined together. So those are joins and unions. Don't worry if you have to go through that a couple of times. I know it took me a while to understand how joins and unions work when I first started this whole data analysis thing. All right, so we're at the home stretch. So we're going to be talking about pivot and pivot longer. If you're familiar with Excel, you might know a pivot table. If you're familiar with Python, you might know this to be called a pivot table and the melt function. So let's correct this little error over there. So oftentimes you'll want to pivot your data like this kind of into a wider format, or unpivot your data into a longer format. And we'll use the pivot wider and pivot longer functions to do this to our data. Pivot wider takes a long data set and converts it to a wide format that's easier to read. So let's illustrate with an example. I find these things are easiest to illustrate with examples. So we have our Netflix data over here, right? If we want to make it wider, let's say we want to, if you remember the type column, remember at the kind of beginning of this course, or beginning of the tidyverse section of this course, we looked at type and we found out that there were only two, TV shows and movies. Well, what if we want to have a different column for TV shows and movies instead of having it in one column? If you think about it, this will obviously reduce the number of rows and increase the number of columns. That's what widening a data set is. You're reducing the rows, increasing the columns typically. So if I run this, then we get a data set where the ID column is country. So by country, we're getting, we have TV show and movie separated. And then we get the values from title and the values function. Basically, how are we crunching down the data? I'm using the length function. And what that's going to do is that's going to count the number of movies and TV shows the number of titles per country per type. So we pivoted our data over here. Think about an Excel, like an Excel pivot table, which again, I go over in my Excel course as well. That is, exactly what we have over here. That is a pivot table. And of course, you can always put a little question mark over here and run that to learn more about pivot tables. Oh, oh, interesting. Maybe you have to do a double question mark. Interesting. Okay. Wait, so this didn't work. Let us try it the way we were doing it earlier. Add a couple of lines over here. Add a new. And then we'll do pivot table. Interesting. Okay. Let's see if we can fix this. Pivot table tidyverse. You know what? I think pivot table actually comes in a different. I think pivot table might actually be for part of the base R package now that I think about it. Ah, okay, yeah. So pivot table. Oh, so it comes from the flat tabler package. So you see, this is where this is how you find out exactly how stuff works. So we're using the pivot table function. I wonder if I can use the pivot wider function as well. So you'll see there's oh, sorry, my bad. I completely goofed over there. We're using the pivot wider function. We're calling it pivot table. So yeah, you'll see sometimes even with experience, you make really dumb mistakes. So you'll see if we do pivot wider, then we get a bunch of descriptions over here where it explains exactly how everything works. Sorry about the confusion. So we can use question mark pivot wider to to find out more about how the pivot wider function works, which you should get used to reading documentation because that's how you learn how a language works. And it is, no one ever knows everything. No one ever memorizes everything. The documentation is a great way to help you increase your knowledge of the language and learn new things as you need them. Remember, as you need them is important. Okay, so another thing that you might encounter is oftentimes you'll receive data in a wide format and you actually want to convert it to a long format. So let me show you guys what we have over here. As you can see, I'm creating a tibble with a couple of vectors. So ABC, and we have ABC 1, 3, 5, 2, 4, 6. And let's say I wanted to make it a bit longer. So the pivot longer is a lot easier to use. Test df, so I'm importing that test data frame that I just created, and I want to make it longer based on the 2 and 3 columns. So now you can see, instead of saying just ABC, and then it now says AB is 1, AC is 2, AB is 3, BB is 3, BC is 4, CB is 5, and CC is 6. Again, it's one of those things you kind of just play around with, and then you'll find yourself understanding it faster than you can imagine. Again, we can always do the, pivot longer, like question mark pivot longer to understand more about this. And if you want to learn more about data cleaning, then be sure to check out the tidyr cheat sheet, which I link over here. Oh, I may have already linked this higher up. Oh, I think I did. And then when I thought I linked the dplyr, I linked the wrong one. Okay, so I'll be sure to correct that in the, yeah, this is tidyr again. So I'll make sure to link dplyr over here. That way you can, in the notes, you'll have the correct version. All right, and that is it. So you see, we went over all of this content. This is all the stuff you learned, and you can go to the table of contents and just see all the stuff you learned in this course. Again, the point of this course is not to give you a comprehensive look at the entire language. I don't believe that to even be helpful for people or at all useful. The purpose of my channel is to give people the skills they need to get good jobs in the industry, and most jobs are not going to require you to learn the entire language like the back of your hand. What we're trying to do over here is I'm trying to teach you, give you the building blocks, kind of like the foundation level you need in order to learn what you need for the specific job that you end up getting. If you are able to do every single thing in this course, that should be good enough that should be more than good enough for an entry-level interview, in my opinion. So again, congratulations. You've reached the end of this free course. You've learned a lot, and I hope that I've explained everything in a way that's easy to follow. Don't feel bad if you need to go through this content again. This stuff can be very difficult to understand on the first go, and this course should give you a good overview of what you need to learn in order to get started using R for data analytics. These skills are really useful, and for anyone who works regularly with data, and once you master them, you can comfortably charge in the upper 5 figures, in my opinion, for these skills. And if you combine them with another thing like Tableau or something, then you could comfortably charge in the 6 figures. My personal experience has very much led to that that assertion. So this is just the start of your journey. Don't be discouraged at all if you need to watch this video 2, 3, 4 more times. But this is just the start of your journey, and I'm really excited to see where you end up. If you like the video, make sure you like it, subscribe for more tutorials like this and other real-life tutorials that I do where I actually show what I do on a daily basis. And if you need any help, feel free to comment in the comment section below. Thank you guys so much for watching this video. It does your positive comments, your likes, your subscriptions, everything are a huge inspiration for me and are the reason that I keep making these videos. So thank you guys so much for your time, and I hope you have a great day.